In this video, we're going to find interval of convergence. Interval of convergence is values of x so that this infinite series will converge. In other words, we are finding the domain of this series. So the center is 0, and we need to find the radius of convergence. So we need to do the ratio test. And when you simplify this, you get this. X to the n cancels out. And as n approaches infinity, you know that this will go to 1. By ratio test, in order for this to converge, absolute value of x has to be less than 1. So we know that the radius of convergence will be 1. And since the center is 0, you go 1 to the right, which will be positive 1, and 1 to the left, which is negative 1. So we know that this infinite series converges from between negative 1 and 1. But we need to find out what happens at the endpoint at negative 1 and 1. By the way, when you solve for absolute value of x is less than 1, you get x is greater than negative 1 and x is less than 1. So you get the same result right here. And the center will be the between negative 1 and 1, which is the same result as we get over here. So let's check the endpoint and see what happens. Let's first plug in negative 1 instead of x. Then you get this series. Now what do you notice about this infinite series? This is an alternating series. And by alternating series test, this series converges. So that means we could include negative 1 as part of the solution. Now what about 1? When you plug in 1 instead of x, you get this. And what is that? That's a harmonic series or p-series. And by p-series test, this series diverges. So we cannot include 1 as a solution. So the interval of convergence is negative 1 to 1, where negative 1 is closed. So any values from negative 1 to, or you could write it as negative 1, x is greater than or equal to negative 1 and less than 1. These two are the same thing. So domain of this series will be negative 1 to less than 1. These are the values that will make this infinite series converge. Now let's take a look at this infinite series and find the interval of convergence. First, the center is at negative 1. And we got to find the radius of convergence. So we need to do the ratio test. So this is what we get when we apply ratio test. And we need to simplify this. So this is what we get. And then you could cancel out 2 to the n on top and the bottom. And add quantity x plus 1 to the n on the top and on the bottom. And these are sign changers. And when they're in the absolute value, they will end up being positive 1. So we could just ignore it. So as n goes to infinity, there's no n in the absolute value, so you just get absolute value of x plus 1 over absolute value of 2 on the bottom, which is just 2. Now, in order for that to converge, you know that this has to be less than 1. Let's multiply both sides by 2. You get absolute value of x plus 1 is less than 2. So now we know that the radius of convergence will be 2. Also, let's solve this. When you solve this, you get negative 2 and then x plus 1 in the middle subtract 1 on all sides, you get negative 3. X is greater than negative 3 and less than 1. So we're going from negative 3 to 1. And you know that the center is negative 1. So from negative 1 to 1, you need the radius of 2. And from negative 1 to negative 3, you also need radius of 2. So this is another way of looking at or finding the radius, center to the endpoint. Now we need to check what happens at the endpoint. What happens when x equals negative 3 and what happens at 1. So let's plug in negative 3 instead of x and you get this. And you know that this is the same thing as quantity negative 2 to the n power is the same thing as quantity negative 1 to the n times 2 to the n. And 2 to the n cancels out. So you get quantity negative 1 to the n plus n, which is 2n. Since this is 2n, even, negative 1 raised to the even power will be always positive 1. So you could say that this is the same thing as this. Now take a look at this infinite series. Well, by the n term test, you know that this series diverges. Because as n goes to infinity, this does not go to 0. Also, think about it. When n equals 0, this will be 1. When n equals 1, this will be 1. When n equals 2, this will be 1. So you keep adding 1 infinite number of times. So the sum is getting bigger and bigger. So this infinite series diverges. So we know that negative 3 doesn't work. So we cannot include negative 3. Now what about positive 1? When x equals positive 1, 1 plus 1 is 2, so you get 2 to the power of n. Now this cancels out, so you end up getting this infinite series. Now what happens to this infinite series? Well, again, by the n term test, as limit as n goes to infinity of negative 1 to the n, this does not go to 0. So therefore, by the n term test, this series also diverges. Also, you could think about it, like when n equals 0, this is the same thing as 1. When n equals 1, this is negative 1. When n equals 2, this will be positive 1. And then you add negative 1, positive 1, and so forth. This pattern repeats infinite number of times. So you start with 1, 0, 1, 0, 1, 0. So there is no finite sum. So that's another way of looking at that this infinite series diverges. So we cannot include 1. So therefore, the interval of convergence is from negative 3 to 1, not including negative 3 or positive 1. So this infinite series converges only when x is between negative 3 and 1. And let's take a look at this infinite series and find the interval of convergence. So the center is at 0. And we need to find the radius of convergence. So let's do the ratio test. And this is what you get as your setup. Let's simplify this. So you get that. Now x to the n cancels out. And as n approaches infinity, you know that this will approach 1. So you get absolute value of x. Now you know that by ratio test, in order for this to converge, absolute value of x has to be less than 1. So we know that the radius of convergence is 1. Also, absolute value of x is less than 1. That means x has to be greater than negative 1 and less than 1. And where is our center? Center is at 0. 0 to 1 and 0 to negative 1. You need distance of 1, so that is a radius of convergence. Now we need to check what's going to happen at the endpoints, negative 1 and 1. When x equals -1, you get this. And notice, the absolute value of this converges. Because the absolute value of that will be this. And this one converges by p-series. So we know that this series converges absolutely. So we could include -1. And now we need to check what happens at 1, when x equals 1. When x equals 1, you get this. And you know that this series converges by p-series test. So that means we could also include +1. So therefore, the interval of convergence is from -1 to 1, including -1 and 1. So we could also write it like this. These are the same thing. So any numbers, any values of x from -1 to 1, including their endpoint, would make this infinite series converge, meaning that this infinite series will have a finite sum.